and welcome back to the Rock Academy. In this video I'm teaching all about mission planning with the Rock R2A LiDAR. In this video I'm covering all about the theory and principles and the thought behind mission planning with LiDAR. I'm going to make another two videos covering how to actually do the specifics of setting up the DJI Pilot app for the M300 to do mission planning and Maps Made Easy Map Pilot Pro app to do mission planning. And these two apps should cover all your bases for every other app in the marketplace. They can all set up a custom camera and do mission planning. So now let's get into the theory behind mission planning. So let me go ahead and draw a scenario here on this board, and we'll start talking about the specifics that go into analyzing and looking at what you're trying to capture in the data in order to set up the proper mission plan to best suit that need. So here I'm going to go ahead and draw a ground. Well, the ground will be in black here. And then let's draw some trees. So now we got some trees, some structures in the ground. Now I'm going to go ahead and draw kind of the drone's going to be flying into the plane here. So we'll have the drone flying into the plane over here. There's our little drone. It's going in. And then we'll have the drone flying back out. Because the way we mission plan, it's always in these lawnmower patterns. The drone's flying out this way and in this way. So it's flying down there and coming back this way. Now, the laser scanner itself, it's a laser, and lasers always go in straight lines. So we know the field of view for the R2A is about 70 degrees. So I'm going to go ahead and draw. This is not to scale, but let's just say that's 70 degrees. We'll draw another one over here. That's also 70 degrees. So this would be our overlap. Let's just say 30%. Again, it's not to scale. And then let's just say this is our above ground level. We'll say 60 meters right here. And technically this distance right here, this would be our flight line spacing. Okay, so now what we can see here is that the laser scanner is seeing in these cones. They're seeing in this cone of field of view. So now if you're just trying to get the bare earth, and that's all you care about in your LiDAR data, then 30%, even 20% overlap, no problem. This is all fine. It's gonna get all the points in the ground. But let's just say this tree right here, let's just say it was a little bit taller. Let's say it went all the way up here. And that's where the tree started. Now, what's going to end up happening, as you can see this cone here, these two cones, and there has this big spot right here in the middle, and all that stuff right there is not going to get any data. It's not seen by a laser scanner. So this area right here, not seen at all. So what happens is that you're going to see these cones where you've cut out the data set, basically. You'll see these wedges that go through the data set where you didn't get any data because you have these two overlapping cones basically pushing around and cutting out everything in the middle. So if you're trying to get the treetops, or let's say if you have these power lines, so you're trying to get all that infrastructure in the data set, you need to start thinking a little bit differently about how you mission plan. Now, if you're just trying to get the bare earth, like I said earlier, this 30% overlap, no problem. You'll have all the data here on the ground that you'll need. Whenever you have structures like a corridor, let's say power lines, my approach to doing corridors and power lines, I'll draw that right now. So for a corridor, I'm still gonna fly at my 60 meters AGL, and what I'll do is I'll fly just off the left tip of the structure, of the whole corridor, and just off the right tip. And this isn't perfectly to scale, but this is basically what's going to happen. This would be much higher, and so that field of view would capture everything inside this cone of coverage here, which includes that whole structure. So if you fly at 60 meters AGL and you just mission plan just off the tip of your two structures using Google Maps, you're going to be fine. You'll have all the data you need of that structure, and you'll get it from the left side and the right side and front and back. It'll all be really well covered. And that's going to be a very high overlap situation. So as long as you're validating that in your mission planning software, you're going to be golden. Now let's talk about a little bit more in general, what do the flight height and flight speed have to do with the accuracy of my LiDAR data? So with LiDAR data, the higher you fly, the less accuracy you get of the points on the ground. It's just like a camera where the pixel size gets bigger the higher up you go. The actual resolution of how accurate that point measures the ground also loses precision as you get higher. At that 60 meters, and doing the flight's coverage of 20% overlap, so you're getting all the data on the ground, at that 60 meters, you're going to be able to generate 1/10 of a foot accuracy on your deliverables using the rock cloud. At 120 meters, so 400 feet, you can still fly this high. You're just going to lose a little of that accuracy. You'll be down around at 2/10 of a foot. And this is still okay for a lot of scenarios, but if you need that extra accuracy, you can fly lower and get the extra accuracy. So what we recommend is that 60 meters and flying at 7 meters per second and doing 30% overlap, you're going to be golden for that 1/10 of a foot accuracy all the time. So I think that should be covering just about the basic concepts of doing mission planning. You can also do crosshatches where you're flying back and forth and left and right on a data set. If you're trying to get more of this 3D objects of trees and you're trying to really capture the tree trunks really well, all of that, you do that crosshatch pattern to get that extra good coverage of left, right, front, and back of an object. In the next video, I'm going to be using the DJI Pilot app and showing you how to set up the Pilot app to actually do this mission planning for you automatically, where all you do is draw that polygon and say, I want 30% overlap and I want to fly this high. So I'm going to cover that in the next video, and then I'll be covering how to set it up on the Maps Made Easy, Maps Pilot Pro app for your M210s, M600s drone systems on that one. And then we'll also be talking about terrain following. So stay tuned for the next one. Hope you found this informative. I'll see you next time here on the Rock Academy.